Okay. Good to see everybody here. My first time in Greece, actually. I'm Paul. This is about CI/CD. And my name is not Greek. It's from Lithuania, but they changed the spelling. Everybody asks me if my name is Greek. Who here is from Greece? Hands up. Okay, good, mostly. This talk is about Dagger. Who here has heard of Dagger before, do you think? No, okay, some, right? There is a Java technology called Dagger. It's not that. And also, it's not about knives, okay? Which CI/CD are you using? Let's go easy one with GitHub Actions. Okay, down. What about something like Jenkins? More, the same, love it. And then they have GitLabs and stuff, other smaller ones. This is me. I do things like this, get into trouble. And I specialize in CI/CD. It's one of my topics. I contribute to projects like the Jenkins project, Dagger, and other things. And I do open source things like this, CD Foundation, Linux Foundation. But despite everything, and this is a slide for something else, doesn't matter, standards body things. CD, so conferences, CD, spreading the word, and I organize conferences myself in Scotland, all right? Anyway, despite all of this, the more I know, the more less I realize I do know, right? And this one, okay? I feel like this guy every day, okay? And my message to you is, if you do not feel like this, you're not pushing yourself hard enough, okay? I wake up every day and I'm like, I feel like such a dumbass. Anyway, I'm a CTO. I do my own recruitment company, but with engineers instead of recruiters, right? So by default, everything you do at the moment, all people are hired to do software things, but you do interviewing and do all these other things, and it's not the best use of your time. So basically, the blue is my team. We are tech people. We come in, and we help with doing the interviewing instead. So you can just write code or do cool stuff, right? I got tired, so I built a company to fix it. So that's that. This is about Dagger, and this is what pipelines, the dream, right? They call it a pipeline. It's a pipe. It goes in a straight line, but that's not reality, is it? This is the reality, okay? Crazy stuff, stuff that doesn't make any sense, right? But it makes sense for the organization. So a pipeline is a straight thing, doesn't make sense. These days, they try to call it workflows because they have logic, maybe more intelligent, multiple branches, microservices, not monolithic anymore. There's lots of crazy stuff. The technology is okay. The innovating on technology like Argo CD and Flux CD, and these are better tools to help with the workflow engine on the surface, but the thing inside it was old and stuck, all right? And this is why the fundamental change in the engine of doing CI or CD or automation tasks, right? Here is a DAG. Who here has heard of a DAG before? Okay, so it's just me, I didn't know, all right? This is rather than like a script that goes 1, 2, 3, 4, 5, this is a better way to architect an engine built for CI/CD because we have dependencies. You need a database to run your tests, right? You need a cache. You need these other things. But then you have to glue them all together, health checks, all that kind of stuff. It's very bare bones. And so this is a smarter way to do it, right? So now we have CI/CD as code that runs anywhere. And that's what you'll see now. So this is Solomon. Solomon is the creator of Docker, and he left Docker, and he created Dagger. So me, Solomon, and the other Dagger team members. So I'll read this out. Your CI/CD pipeline should start on a developer's laptop. If it only starts after a Git push, you're slowing your team down and throwing money down the drain. CI/CD shift left is the lowest hanging fruit for engineering efficiency. Right? So current problems with CI. You may be happy with your CI, but there's still problems with it. It doesn't work on your machine, your local, native. And it's something called push and pray. Push and pray is you make a change to the pipeline, you push it, wait for the internet to happen, do all these things, and then, oh, I forgot a semicolon in my file, or there's something wrong. And then you do it, and then you push, and you wait. That's push and pray. Okay? Who here feels familiar with this workflow? Okay. Throw it in the bin, kick it, right? This is basically, and the last one is complex stuff, right? This one, the Dagger pipelines do work on your native machine locally. No more push and pray, and you can choose your programming language. You can mix and match, okay? This is the Dagger engine. It runs on any Docker container D runtime, okay? Any machine. You can just install it with one command, like brew install Dagger or whatever, right? So it eliminates push and pray, and basically it's all the same engine. If you're on the local, or if you're on these things, it's just code. Code that runs anywhere, in theory, right? So the old way, here are some examples. Docker files, right? Docker file is good, but it's a text file. It's not code, right? It does things, and we try to put code in here, but it's still a text file, isn't it? So the technology of Docker is good, but the way that we interface with it is bad, because it's just text files, and then you put crazy stuff in it, right? You start to write bash in a text file, then you give it to an engine, and then it runs it, and then hopefully it's okay, right? Also note that to do a Docker build, you have to get the whole thing or nothing, right? You cannot stop halfway in the middle and go, hey, I want to debug some stuff, and then go, okay, and then let it go. You can't do that. So the interface between these technologies is bad, but the technologies is good. So Dagger unlocks a new way to do this. It's not really for CI/CD. It's just very, very, very good at it, but you can use it effectively for anything, just building containers all day or running tests, but you're not even doing continuous integration, right? Here's more crazy things. Bash files, replacing. In Python, it's just like string replace, right? Or Java, like string dot replace. That's easy stuff, right? Basic, like programming 101. Here we have to do all these weird workarounds, right? So it's kind of, doesn't feel right. Here is Docker Compose. We are familiar with Docker Compose. Okay, we like it, but it's YAML, because it's shit, right? We don't like it. You can't debug a YAML file, right? You cannot reuse. It's not reusable. We have to copy and paste just blocks or files, right? There are some YAML hacks and stuff, but that's a workaround. It's not the design. So also bad, right? And here's like a database. You want a database, cool. Well, you have a DB. Can you see this okay in the back? The colors? Is it okay? Right, good, thank you. And down the bottom, health check. So we have to start writing bash commands in a YAML file to run something to check if the health is okay, right? I'm pointing things out because you will see more things. And then on GitHub, you have to start doing weird things like writing bash in a YAML file on the internet that runs somewhere, hopefully, okay, right? So you see, and so on, and so on, and so on. Right, so new way. Look, this is Python. Looks like a Docker file. Works like a Docker file. But it's not a text file, it's native code. Now, the way this works is when this gets executed to each line, the Dagger engine transforms this from and this with directory in the exec into a GraphQL query. People who is familiar with GraphQL, is it even conceptually? Okay, good, so we're on it right. Okay, so basically what this is, it's a query builder. It builds a query, a massive graph query. And the DAG is a directed acyclic graph for a GraphQL, and it scans all the code, and it creates a query, and then it throws it into the Dagger engine. This means that any programming language will run the same stuff. So you could take this code, and you could put it into AI and say, convert this into Golang or TypeScript or Java, and it would do that, and it runs the same. So all the examples on the Dagger documentation, it has tabs, Python, Golang, TypeScript, right? Because it's all the same, because it doesn't matter, because it's going to be a GraphQL query anyway, and it hits the Dagger engine, and that does the containers and the services and the dependencies and stuff, right? So now we can, rather than having DevOps team and Java team and Python team, and you have kind of your own scripts or your own stuff, you can create something that can effectively, you go, oh, okay, the other team know how to spin up this thing and run these tests, but it's in a different language. It's okay, because we can effectively copy and paste it and change it, rather than bash and weird things and YAMLs and things like that. So now we can have a bit of a shared, reusable thing also, right? Separate teams, but the same programming language, you can just literally take the other team's stuff and run it, because you understand it, because you're their Java devs and you're Java devs, right? So services. This is what a YAML file looks like, and a YAML file. And this is what it looks like in code. I have the next slides in two parts. The first part is the database. The second part is the application. So, should look the same, right? And in that variable, now we have variables. Variables are code. Variables can be arguments. You can just pass them to a function. So you say to a function, so if a function, you could just write a function and say, give me a database as an argument. Do stuff. So now it's just a variable. Right back to basics. Simple stuff. And then here is the service binding. Do I have a thingy? Oh, cool. I don't want to touch that. I'll break something. Like that. Yes, okay, fine, my back. But it says with service binding, DB is the host name, or the key in the YAML file, which becomes the host name. And it's just a variable. And it knows in the code it has types, right? Like dagger.service, dagger.container, dagger.file, dagger.directory. So it knows what it is. It knows it's a service, and it just binds it. And now it knows it's a dependency. So now we can do dependencies on the DAG, and we can have health checks to say, I cannot run this code because I have a service and I depend on that service. So we're going to make sure that service comes up first. I'm going to make sure that health check is passing, and then it's going to move on, right? So you don't have any work to do. You don't have to think about pings and health checks or nothing, because it will do it for you. Making sense? Cool. And the last line is as a service. So it returns a service object. So it knows it's a service. You can just pass the variables around, but it knows it's a service, so you can do things differently, right? And self.build is, you'll see in a second, right? Hold on. Okay. So before was this example like this one, right? In one function, it's a database, and then doing something, return the service as the web application as a service, right? As well, because it's like an API. So there's technically two services here. Now, what if I want? Now you cannot reuse YAML, but you can reuse code. So here I made a function called Postgres, and the argument is the string version. So now you don't have to copy and paste blocks of stuff. You can have one definition of how to bring up your database, bring up your cache, bring up your other API, bring up whatever you want. And you can just provide arguments to it, right? Full reusability. The answer was always code. They tried to run away from all the code, but turns out the answer was here, all right? And as you can see, yeah, function. And then here is serve, right? So bring up my application, and as you can see now on the right, it just says Postgres 18. I can change it to 17, 16, right? So it really is that simple, right? And databases and Redis this is TypeScript syntax. It's all the same, as you can imagine. It's just and so on and so on and so on. Health checks, because it's yeah, okay, move on. So I'll do a live demo thing, which is obviously not going to work, but hey ho. Okay. So this, if you're on a so this is basically a Git repository that's empty, right? Your project. You've not Daggerized it before, right? Dagger init SDK equals whatever programming language you want, right? It will generate the stubs to begin with. So Python, TypeScript, Golang. And I give my project a name. I think its name equals. I can look it up if not. Now, you're going to see some stuff happening. When you run a pipeline, it's not to like run it on the internet and you get log outputs. It's an interactive engine that you can interact with, right? You can peek into. Hold on. Timeout. Internet is a networking problem. It always works. Doesn't matter. Anyway. This should work. Okay. So this is Dagger functions. And Dagger functions basically, if you look here, this is a Python function, but we have annotations called function. So there'll be functions inside the code that you want just to reuse things, but the at function is external, which means it can be called as a pipeline. In your GitHub Actions YAML file, you can call it. In your local machine, you call it. It's the same. So it's the end. It's an entry point, right? So here I have self-env, which you don't know what that does yet, and then I'm adding things on top. So a Docker build, to get something to, you have to do the whole thing. Whereas with Dagger, you can stop at any line and just say, you can debug it there, you can append things. So self-env is a function, and here's env, right? Take a look at this. Remember, this is being called from other functions in the same file. We are repurposing and reusing. So this is scratch container, give me nothing, right? Give me from Python. And then self.source. So what is self.source? That's the copy command in a Docker file. Copies your code into the running environment. So it's just an argument at the top. And you can do things like, give me without this directory, without that directory, so you can filter. Right? Kind of like what the Docker ignore file tries to do, but it's a text file, and you can do it only one time, right? Docker ignore file is global. Whereas here you can say, okay, I want my directory, but before I use it, oh, this case, in that case, in this case. So stuff like that. And then run pip install. So that's env. So I basically have a base environment for my application, but now I can only sometimes add these environment variables, sometimes download these packages, but not for every time, not for production. And here is like self-env. So it's a build. And this will host it. So self-env, you see I called it. But I don't have to expose a port. Maybe I want to expose different ports because there's like multiple of them. So self-env doesn't expose a port. It just gives me the basic packages. And then in this case, I can expose this port, and then I can host it, right, on port 8000. And I can do Dagger call build. Dagger call on the command line, build, and then it will run this, right? Oh, I'm not on the internet. That's why. I must have disconnected. Interesting. That would be why it didn't work. We need internet. Let me try again. Now, when it's running your pipelines, you can peek into the inner details of the engine and up again using the plus and minus keys, right? And so here I have Dagger engine. So let's do Dagger call test, right? So it's just loading, scanning the code, generating the query, and then it does other things. And I can press the plus on my, okay. So verbosity, don't know if you can see it says verbosity at the bottom. So this is all the steps of my stuff, right? It was very fast because it's cached, right? Because guess what? You can cache your pipelines. So you know how you have a step down here, but you'll have to run it everything to get to this point every time? Because the Dagger engine is built on the Docker engine, and Docker layers are cached, now your pipeline is cached. You can cache your pipeline. So pip install is the cache point, and you don't have to wait for pip install to run every time. Or npm install. npm install takes forever, right? It doesn't take forever because if nothing has changed, if the package JSON is not changed and their source code is not really changed, why would you run npm install over and over? Well, you have to with the current technology stack, but because it's intelligent, you can cache your pipeline steps. It doesn't have to do it. So now everything is faster for free, right? I will show you now more things. The Dagger call test. It was too fast. I'm sorry. Next. Dagger up. So this is like Docker Compose up, but kind of like Dagger. We don't need YAML files anymore. Dagger up. If I go to the code, so here's a serve function, and as you see, it's got at function, so it can be Dagger call serve, but you can also have up functions. And up means it's going to bring something up, like a service, right? And this is special. So here is serve. So there's a database. That's a service. It's at here. It's attached to here as a service, and that's that. But it's up. If I type Dagger up, it will boot it up. And I'll do plus and plus. So here's module source, that's mounting code, etc. Boom, see the green? That was a health check. That was like, no, 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 yes, now it's up. Then I can go to that in my browser and see the API, right? So if you have code for your application and then code for your pipelines, they don't have to be separated anymore. Sometimes you have YAML, Docker Compose files for local and Docker Compose files for your CI, right? This is quite common. Don't need that anymore because it's just code. It's one thing, right? Anyway, that's that up. I can just kill it. It's dead. So just trust me, it's up. So that's like up functions. Same code. You can just make it as an up and run it in your browser. Dagger shell. So Dagger shell is for debugging. Now, if you're in one of your functions and you have a problem, like an error, you can just change this the return value of dagger.container to dagger.terminal. When I run it, it gives you a shell right at the line that you want. Here I can just return. I can return a terminal like this. So because the other ones, they return container, because every line returns container, 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 because it's a state. It's a running, it's like the build state and the run state of Docker in together in hybrid. But I can just return a terminal at any point, and it will stop. So you can debug stuff, test scripts. If your test suite is broken, but the Docker container dies, or something dies, you have to get, how do you get access to that environment then during the Docker build, or during a Docker Compose run, or something. This is the answer, it's terminal, and it will just stop, and you can go in and debug. Right? There's a Dagger shell. Which you can boot into, and you can just call these, you can do things from inside. You don't even need to write code. So see every one of these lines, this with directory, from, with exec, you don't even have to write code. You can just write it into the shell. So it's like a tinkering, like a playground. Right? I'm not very good with the syntax, but you can do like container. Oh yeah, so it has an autocomplete in the shell. From build. Anyway, I don't know that it's all in the documentation, but you can do like container from Python, pip install with exec, run this command, see if it works. Right? So you don't have to actually run a pipeline to test around. Anyway, here I can also just call like test. And it would do Dagger call test, like on the command line. I'm inside here. So it's like deep pipe code debugging. I'm killing this. Okay. Next. Multi-stage builds. Who here knows what that Docker multi-stage build is? Okay, not so many. Sometimes you don't want to, when you're building or testing your software, you have lots of dependencies for building it or compiling it, right? If it's Golang or Java or something, you're compiling it. But in like in JavaScript, you have like node modules, or you have all these things for compiling and doing stuff, transpiling. But to run it in production, you just need .js files, right? So you don't want to have like 800 megabytes of stuff that you need to build and compile your software and running and going to production image. So Docker has something called Docker multi-stage, where you have like this. At the bottom it says copy from container D, copy from. So it's copying just some binary files from the above. So it's like compiling to a binary, and then in Docker you can just take from the previous container and only the files you need, and then run it. So your image is very small in production. That's the point, right? It's common pattern for optimizing Docker. Here is Dagger. So now it's just a variable. So the Docker go build, so all that stuff. But then in production, I can just have an Alpine image with a binary, right? And then run. And then I do dot publish at the end, and I can publish that image. So, but it's prod image. So you see, they're just variables now. So this is effectively the same concept, but it's being coded up. And it's just code, so it's functions, repurpose, whatever you want, right? We also have a profiler. How do you debug your pipelines right now? You look at log file, log output, right? Standard out. But standard out is only the output. What happens all the inside? What other stuff is not outputting? You have to go in and add like debug statements to, output stuff, right? That's it, basically. Dagger has a built-in profiler. So let me give you an example. On your command line, if you do export AWS key equals and then the key, or open API token key, well, the same here. There is the Dagger cloud. It's basically your cloud-based place for all of your Shiny builds. And here you have a full inspector for every single step of your code and pipeline and the underlying steps that triggered that. If it's with directory, then what you're copying code, you're copying directories. It will show you every step that the engine is doing. It will show you the time, the speed, networking, disk problems, networking problems. You can't debug this stuff if you're just doing standard out, spitting logs, right? It's all here, and you can inspect it. This is a run. So every time you do a run, a Dagger call something, it will output the URL onto the command line somewhere here. It says, look, full trace at. You click it, bang, opens up, and you have your thing. This was me messing around with the shell. So obviously there's not much to see here. But yeah, you can peek in, you can zoom out, and see all this stuff. So container from Python 3.1, directory, app, working directory, mounted cache, with exec. So check this out. This is magic, right? See, it says with exec. It's a different color. It has this little icon here. It says cached. And what is the line? It's pip install or npm install, which could take 1, 2, 3, 4, 5 minutes, right? So it's cached it. So there's the evidence. So what would now you're just shaving time off your pipelines for free, right? Time is money. And imports. So you see this icon is a cached step. If you want to bust a cache, you just change anything on the disk. But remember, this was generated from my local computer. So if you have a problem with your pipeline, you can just go here, make public, send the URL to your colleague. He can debug all the steps and go, aha, I see this. Look, you have a problem with your network or you have a thing. Okay? So now we can debug each other's pipelines. And you can save it rather than just looking for the standard out, which you could spend a long time there. This making sense? What do we think of this? Oh, and it's free. It's no catches. There's like enterprise packages and all that for magical features, but just to use it, you get every step. Modules. More. Here's another one. I mean, here's the standard out, right? This is what you're used to looking at, just standard out stuff. But it's the mechanics of how we got to that part, right? Here you go. So these every test. So the way that this was structured, there's a function in the code, in the pipeline, and they're just running that over and over, right? There's lots of tests, right? Test to test things. And so here they're separated out in the Dagger file so that they can be used to open telemetry, yeah? So this is just an open telemetry standard, and it's in Dagger engine, so all of your pipeline steps are all telemetry watched, and they go up to the Dagger cloud, to here. So yeah, you can see the time of each thing, tests. So this is actually the Dagger engine itself. These are tests of Dagger. So, one of the profiles. So something sync here, you can open it up, see loading things with exec failed, arg false. Obviously it doesn't mean anything, but the point is you can inspect anything you want and the deeper parts of it. So yeah, that's profiling. Next, more cool things. Who here works in software that has to work for more than one architecture, like multiple architectures? Okay, they're called matrix builds. They might look like this. Have you seen this before? Multiple operating system versions, right? Ubuntu this, Ubuntu that, Windows this, Windows that. Now, this is only this is the very beginning of on GitHub Actions of 300 lines of magic crazy stuff. This guy's nodding. He's sad, right? He has trauma. But anyway, so I have environments, versions, operating systems, and then and databases and all these things. So that's hundreds and hundreds and hundreds of lines of YAML. And to debug that, you'll be spending days. How could it be better? right now, there's no way until you do it like this. So here is code. It's an array of architectures. And then the first line is, rather than give me scratch container, which is the default, you say, give me a container of this architecture, right, which is one of these. ARM, AMD, some weird IBM stuff, and then you do your things, right? Look at the first line, for platform and platforms. It's just a loop. So you can just loop code, just like in any for loop. So rather than trying to have some weird cloud-based YAML thing to figure it out for you, you can just write a for loop and just loop through all your stuff. And inside, it's the same code, or it's a function, or there's things in here that are other functions in your code, and you're just repurposing the code over and over with arguments. You see, in the beginning, we had different versions of the database, different versions of the application. You can effectively just have those functions ready, and then you can have multi-architecture, multi-stuff. It's just for free, right? It's just a for loop now, not magic. And here's another one, Golang, building Golang apps. So Linux, Darwin, AMD, ARM, and it's just a for of fors. It's a nested for loop, see? So even like DevOps, people who are not proficient in DevOps or anything, they just know how to write code. Some data scientists somewhere, they can actually start coming and write things like, hey, data science team, go and write something that does multi-architecture, multi-testing things. They don't know anything about cloud or software engineering or unit testing because they're data scientists, but they know how to do loops and data structures and stuff. So they can start actually writing code, and it's just a function. So if you think about it, your pipeline code is not hidden away anymore in some kind of YAML file or proprietary technology, right? That only works in some companies or technology stuff. You can import, because your pipeline is a TypeScript file, Java file, at the top you can just import other files. It doesn't matter what it is. So if these are loops that do stuff, then you can just start importing libraries. So if there's like cool libraries for replacing strings, generating timestamps, generating stuff, well, you have to write your own basically in Bash or something because you're writing in Java, but it's Bash land. But in this case, you can just you can do pip install some cool package, import it, put it into your pipeline, start calling it. So now you have the entire Python ecosystem inside your pipelines. You can just use it, or Java, or TypeScript, or Rust, or PHP, right? So now you have the all programming world, and you can just import. That makes sense? Import stuff. It's one line to install Dagger, basically. As long as you have Docker installed, you're good to go. Here's another thing, concurrent functions. So it's similar to the matrix build, multi-function, but that was a loop, right? That was a for loop, so it was doing it one over the other. Here is an example of, you can just do, let me see, can I make this larger? Okay, so this here done, this function is called build-env, which is, again, just gives you your basic build environment with npm install at the bottom. So now you have your code, your application's ready to go. And then build-env is, now your basic, once you've got a couple of functions, your base function, which would be your Docker file, then you see here, it's just doing build-env, which returns a container, and then you can do things like with exec. So there's a with exec, so this is run the unit tests. This one's run type checkers. This one's run a linter, right? But you see now your code, your pipeline code becomes super clean, because it's just like one-liners now. And you can append and append and append. Rather than Docker build or Docker, it's just like one big thing. You can just pause at any point and continue, because it's a container. And this is a Python library called NAIO, I guess, for multi-threading or multi-stuff. I'm not really a Python dev, so I don't know what it does. There you go. Import NAIO. So it's a concurrency library, right? You could do the same with Golang or Java or whatever you want. Anyway, so NAIO, create a task group, and then these three guys. And it will just do them all with native concurrency rather than some magic. Yeah? So now this is where we're actually importing things from the Python ecosystem and up to supercharge your pipelines. So So there's maybe some limitations on what you thought was possible before, but now there's no limit because you can import any library and do cool stuff, right? Let's see. AI would not be a great talk without AI, right? This has an AI agent and an MCP server built right into the Dagger engine. It can build your pipelines for you. It can fix your code for you. It can write tests. It can build pipelines and debug pipelines without you doing any work, right? Here is an example of the agents. So they're native. So every file, every function that you write, every test that you write, this Dagger understands all of your company's code, because it's the things use like a Dagger file or a Dagger directory, a Dagger service, right? So these are all Dagger types. So it knows what these are, and you can. Here's an example. Again, so you've got Golang, Python, TypeScript, Java. It's all the same, right? Here it is. So basically, you create an environment. It should look kind of the same as your pipeline code because it basically is. It says basic environment. It receives an argument called an assignment, which will get called. Here's a container. So what is the container used for running this agent thingy? It's Golang in this case. And the output, right? So these are key names. Doesn't matter about that. Here's the cool. So it's called dagger.llm. As soon as you call .llm, you give it an environment for that LLM to run inside, right? You might need extra tools. And here's a prompt. You're an expert Go programmer with an assignment to create a Go program. Create files in the default directory in builder. This is an argument, $builder. Always build the code to make sure it is valid. Do not stop until your assignment is complete and the code builds. Your assignment is X. And so it can do stuff. This is really cool for if you have a Terraform files with Amazon IAM permissions and all that. You could just say, you don't have to actually write pipeline code. You can tell it to just scan your files, scan your Terraform files, pull in this other security library, tell you things, fix the things, push it as a pull request, basically. But it'll do it all inside. Or call parts of your own existing pipeline, like run the tests at function test, right? But here is an example of, in this repository, we have, not AI, we have other things. Here. So this is the fix. Diagnoses test failures in the source code and fixes them. So basically, it's going to it uses prompts, basically. So if any of the tests fail, it's going to automatically fix it and then push it. So this part of this one is GitHub. So it'll just do current module, source, get fixy things, do a diff, and then do dag.github API. So Dagger, of course, has modules built in for things. You can make your own modules for your own projects or your own things. And it's this simple now. So this pipeline step, you can run it. So GitHub API, create PR. And then there's your commit body and the diff. Create a comment, and then bang, and it'll do it. And then this is part of your pipelines. So this is kind of what I was saying about Dagger is, of course, amazing underlying technology for CI/CD pipelines, but people are also just not using it for that. They're using it just for full code automation. Bring this service up, call this service, test it. Okay, it's broken, check the code, make some test fixes, make some code changes if you wish, then do that, then make a PR, and then publish the PR, and then go, hey, right? So there's kind of automation engine as well, right? Anyway, there's a lot you can do. It's up to you what you want to do. So, here we'll finish. So just a small, quick recap, very, very fast. So the underlying technology of this is Docker, but on steroids. It has layers. Dockerfile has layers. Your pipeline has layers. Every single step of your pipeline is a layer. I can cache that too, if you want. And CI/CD pipeline is on your local machines. It's the same on every machine. It's just code. The only thing that changes is the secrets. Of course, there is native types for secrets. Dagger knows what is a secret and what's a string. So same code, it's just a different secret for the cloud. Or not. Therefore, it runs on the same on every machine. Right? And we'll end there. Thank you.